All right, you ready? Let's start the first one. So, Memory Forensics 101.5. We're not going to go super low, but we'll scratch at some things to look at here. We're not going to do it from a badge carrier perspective. We're not going to do mobile devices. Those are fun things. We have a poll at the end to get some interest here because forensics is a very deep and very broad category. And so we want to see how much SecDSM wants to dig into it. So we're going to scratch the surface tonight, but we're not just going to do like a really simple demo. Like we're going to do a red-blue team type of talk here. So we'll see how it goes.
All right, let's go ahead and get started. All
right, so I'm Ben. I'm a security guy at Dwala. I formerly did a lot of old school forensic investigations at an ISP/enterprise. So some on the outside with customers and law enforcement, some on the inside with like insider threats, HR issues, stuff like that. So I do want to talk about old school forensics and what's changed, because what was state of the art 10, 11 years ago is totally a waste of time almost, and we'll talk about that. So what did I do in the past? Used a tool called F-Response, which exposed iSCSI to suck images over the wire. That's still around, still works fine. There's an enhanced version of DD that I used, Forensic Toolkit, Sleuth Kit, and a whole lot of Perl. I like Perl, so if you want to talk about Perl golfing later, let me know. And then a lot of registry, browser artifacts, and timelining. So we're going to show some advancements in forensic investigations, leading into memory forensics from a blue perspective. I play defense. I'm not real good at offense. That's why the other bald guy in a black t-shirt's over there. And if time permits, I'll probably share at least one story about old school and what we're kind of moving into.
Okay. All right. Hi, I'm Nate. I pen test your company. Yeah, I'm a pen tester for Leidos Commercial Cyber. Sorry.
That mic's not very loud.
It's not? All right. Yeah, it's fine. You can come over here if you want. Can you see?
Pretty cozy. All right.
This little engineering here. All right.
It's on.
All right, so Nate Subra. So I'm a pen tester for Leidos Commercial Cyber. And then I also am a traditional guardsman out of the Iowa Air National Guard to do cyber operations. I do a lot of offense and defense, so usually kind of a closed loop deal. Goal here today is to kind of provide like an attacker perspective. So we're trying to kind of a new form of talks where you get to hear from both sides at the same time. So you can kind of hear everyone's opinion and perspectives, and then hopefully just get a little bit of deeper conversation going. So, all right.
All right, so memory acquisition and processing is the new normal. This is not cutting edge. It's what's expected these days. And the reason is, like when you acquire a disk, you have files, and you go through the file system. Well, files are armored, obfuscated, packed, protected, right? Processes are naked. They have to run on an operating system. They have to run on a CPU. They are running naked, and we can go at those processes and find good information. You just can't hide it. It has to come out of the dark. It does scale. You can't DD every endpoint in your network. So has anyone ever done that? Like taken a box, turned it off, DD'd the disk, got the partitions out of it. Anyone done that? Okay, yeah, that's like really painful. There's still some value in in doing that potentially on the role in the organization or whatever you're doing. Chain of custody is still super important, but memory forensics are very important. You're going to hear why tonight. Tools have advanced quite a bit. We're going to talk about those. We're not going to talk about Redline too much. I wish we could have had time, but that is a GUI-based approach from Mandiant or FireEye. That does a really good job. We're going to talk about Volatility tonight. We're not going to talk too much about Recall. That's a fork of Volatility that Google has taken on along with GUR. That seems pretty awesome. I just have not done much with it.
So moving on, just one side comment. You can totally DD every endpoint in your environment. So, DDIF/dev/null. All right. So.
Oh yeah, I just saw this tweet today and thought it was funny. The new OSI model is much easier to understand. It's all software. But like software runs with memory, and memory has information, and it's important we can go after that memory. So as much as that's funny, we get a chuckle. Like. I thought it was kind of germane to what we're talking about. We're talking about memory tonight.
Yeah, I look forward to writing SDN malware soon in the near future. So, all right. So, this is yours.
Oh, this one's me too. So let's go back to the dark ages, like 10, 11 years ago. what did an incident response or forensics team do? And it was mostly forensics, not as much incident response. Incident response was pushing out DAT files to your antivirus. It was not what we do now. So if it's on, leave it on. If it's off, leave it off. Do you pull the network cable? Maybe, maybe not. These are the decisions you make, and then you acquire the blocked devices. And maybe some running processes, typically like with a batch file you run to put stuff in a text file, and then you harvest that. So you kind of trust the operating system. You're not waiting for a kernel mode rootkit to lie to you. You call the NetFlow people. I put that in there for Brandon. I don't know where he is, but you want to get information off the network, and so you have to call the NetFlow people to help get some of that. Because 10, 11 years ago, I don't know if Splunk was even around. Maybe? I think it was all syslog.
I think it was open source at that point.
Long time ago.
Some kids get help. Yep.
Physical memory acquisition was bleeding edge. Pretty much you did strings and grepping to get information. So while it was possible, it really wasn't that common. And remote acquisition was incredibly hard, and bandwidth made it super challenging. And I did do this. So like that's not just fake. Like I did do this at a big network, and it was really painful because if the machine reboots, you're hosed. The network itself, blips, you're hosed. So it didn't work real well, but that's a way to do netcat to get a compressed stream of a DD image of a blocked device. So that was pretty badass 11, 12 years ago. And then what did you do with that information? You analyzed the file systems, the application data, and you looked at strings, used dirty word lists. Are those still around? You still do those, dirty word lists?
I don't.
So like as you do an investigation, oh, that domain is interesting. I guess they're called IOCs now, but you had dirty word lists and you do grep-f.
Oh, those dirty word lists, gotcha.
Yep. So that stuff. Lots of grepping, registry files. So you go through timestamps and registry keys, browser history files. Used to go after the index.dat, SQLite databases for Firefox. And you ran antivirus to find evil. And then a lot of file carving. We'll talk about that a little bit too. That sucks. I think it's gotten a lot better, but it really sucked. I'll talk about that. When you're done, you create a timeline, correlate activities, other sources of data. So that's the dark ages. That stuff works, but not that well. So I'm going to give an example of the dark ages. And this one really happened. We can talk later about the details. But HR called and said, hey, can you find some evil on a multi-user machine at a remote site? I said, maybe. Can I go there and get the device? And this is like 11 years ago. And they said, no. So there's limited interrogation over the network. And I said, I can't do a whole lot here. It was browser-based what happened. So they said, all right, don't worry about it. 2 months later, they called me and said, go get the machines. We'll make you president if you figure this out. And my team figured it out, but I was not made president. But the HR lady told me that. All right, so we went to the site, got all the devices that were potentially used, and we did like a redeployment. So we brought the deployment team, they gave them new endpoints, brought them back, locked them up, chain of custody, and spent overnights, weekends DDing. And I don't know if you guys remember the freezer trick to get a rotational drive to work. We did the freezer trick. We converted errors with DD to write zeros. We finally got it. We did analysis in Linux. We mounted via offsets, the mount-ro. I don't know if that still works, so we still do that. Used MMLS to get the offsets. Nothing of interest on the NTFS volume. Time for file carving. And we did do strings against the swap file or page file in Windows. So we used something called Foremost. That's still around. Has anyone ever used Foremost? Nice. What Foremost does is it goes across a block device looking for magic codes for like a JPEG header, JPEG footer. So you configure it, and it goes through the entire block device, what you've acquired, and it tries to find fragments and then carve those out. It gives them a random stamp of a file name, puts them in a directory, and keeps going. So my team did this, and it filled up a 40 gig drive. Or sorry, an 80 gig drive from a 40 gig drive, because there's so many false positives, and then it goes back and then starts carving. So we had to actually write a wrapper for Foremost that did a plausibility check. So it tried to open the fragment, true or false, is it a JPEG? And if it couldn't, it deleted it, logged it. If it could, put it in a directory for an analyst to look over. And so HR's calling me, you gotta get this done, gotta get it done. And with like hours to go, we found the two images. They were not cool images. And so we gave those to HR, printed them out, did chain of custody, and like, that was pretty advanced 10, 11 years ago. I don't think this would be very effective now, but I wanted you to have that mindset of like what was cool 10, 11 years ago. And we didn't use memory. We probably could have and should have, but we didn't at the time. So that's the dark ages.
Let's see.
Oh, I got one more. I got a lot here. Sorry, man. So we wanted to look at, well, what's the history of memory forensics? So we put this together. This is our interpretation. So it's not from Wikipedia, it's from Nate and I kind of chatting over the last couple days here. So let's just start in 2005 or before, because that's when I first started doing the forensic stuff. File covering was around. Foremost came out of the Air Force, and so they were doing that. F-Response was around. They started in 2003, but it was kind of shitty. Eventually got better. So you use DCF-LDD in the Coroner's Toolkit. All right, then mem parsing at the Digital Forensics Workshop started to become something that they did. You do more strings, lots of hardware, write blockers, Fred workstations. Anyone have a Fred workstation? Ever see those? Massive, from digital intelligence machines, lots of bays. All right, so then private browsing came out. We were all like shitting our pants. Oh my gosh, private browsing, how are we gonna do forensics? It's not hard, but that's why memory forensics is important. So you started doing mem dumps 2006, 2007. Volatility 1.0 came out of Black Hat in 2007. Encase did some memory, but they finally had their first standalone utility in 2008. If you're a badge carrier, you're probably using Encase. If you work at Enterprise, you're probably using Encase. I don't care for it, but it's fine. It works really well. Registries in memory, you can carve a lot of things out. We're not going to touch on that tonight, but you can certainly do it. The Mitra case is really cool, and I could talk about this for a long time, but in Madison, where I worked for a long time, Mitra was a student at the University of Wisconsin who broke into the closed band police radio system, and every time a badge carrier would radio something around Halloween, he would play about 5 seconds of porn moaning. And this really pissed off the feds, and rightfully so. So they caught him, triangulated him, locked him up. While he was in prison, he kept asking for his workstation to be given back to his family. So much so, it started tipping off law enforcement who'd worked in the case. So Cindy Murphy, who was a detective in Madison when I worked at the phone company in Madison, and I got to know her quite well, did some memory analysis and found, and not all of this is like, you can't find all the true details out, but either found a key in RAM or an artifact in RAM that allowed her to decrypt the files. They found kiddie porn. The guy was sentenced again when he was in prison. That's the first time memory forensics was really known to affect a court case. And then the guy killed himself in prison. So anyways, the Mitra case, really kind of watershed moment. Crypto key recovery, that's why I put it in there. And then there's so much since then, we just kind of said there's a blur. Forensics became incident response, and then threat hunting became something we talk about. And that's not just marketing. Like, you hear a lot of threat hunting marketing. It means knowing what's good, looking for evil on a routine basis, and then finding indicators of compromise, finding the rest of the evil, containing it, eradicating the adversary, and reporting. So what does that mean? We do live response now, not on machines that have been sitting and collecting dust. Volatility is at version 2.6. There's recall and GUR. We talked about that as a fork of volatility. Redline's advanced. It does Windows 10. Finally, indicators of compromise, threat hunting, and now there's forensics on Alexas, drones, cloud, you name it. So we've come a long ways. You want me to do it? I'll do this one. Yeah. Or do you want to do it?
No, I'm good.
All right.
I got my good slides.
All right, so where are we now? So Google had a presentation at the Digital Forensic Research Workshop in 2016, and I thought they kind of captured it with this quote: memory analysis is now a routine and essential technique in triaging and responding to security incidents, period. You just have to have this capability. And you want to operate against real memory, not necessarily an image. Scale and speed are no longer a function of Fred workstations and write blockers. The whole host-based stuff we talked about a little while ago is near worthless against a kernel mode rootkit. It turns your workstation into a pathological liar. You have to go after RAM. Operating systems sign their binaries. This is awesome. We're not going to touch on this tonight, but if you sign a binary, you can have some level of trust. Maybe not all of it. We'll talk about a signed binary in a little bit, but like that will help you get some of the signal-to-noise ratio in your favor. You can extract a process for external analysis, not a file from a file system. And there's agents to help do live response. Carbon Black, GUR, Encase Enterprise, etc. In this last one, I thought I was being real clever here. But OS Query helps you get trust, but memory forensics is for verification. Last thing here, be careful with virus total. It's great. But if you are an organization and you have an indicator of compromise, when you share that, your adversary may see that you shared it in virus total because they have an API subscription, and now you're playing a little bit of cat and mouse. So I'm not advocating for not sharing. Just be careful about when you share indicators of compromise.
Last one.
Last one, we hope, yeah. So I'm going to talk about the blue stuff. Nate will talk about the red stuff. So everyone uses browsers. Is that the first thing you fire up at work? Pretty much a browser, right? Endpoints have tons of RAM. This changes paging and writing to disk. Lots of cloud, right? Google Docs, Office 365. And adversaries work way too hard to have malware that they want to write to disk and give away. They're going to use code injection, rootkits, et cetera. Scale. Stop doing autopsies and use technology and automation to find problems across many systems. And we're shifting from an investigator to an incident responder, IOC generator, and doing threat hunting. In Vault 7, that was the CIA's dump. The initial infection occurs via PowerShell. That's interesting. We should talk more about that, Nate. Puts DLLs in memory, and then there's no disk footprint during the attack. So that's really interesting. We'll talk more about that. And you have no choice. Host got a kernel mode rootkit. You got to do this.
All right, so I let him wind up, so now I get my slide. No. So memory forensics, why red? So I just want to give a little bit of an offensive perspective to this. So hoping that we have some, I know we have at least one in the room, so high five, Nick. And Tom is around here somewhere. So I'm just curious, actually. Did anyone do like offensive, like pen testing, red teaming at all? All right, cool. Well, yeah, you don't count. You get your own presentation. Don't creep into mine. All right. So memory forensics, why? So from a red team perspective, and so if you don't do this, that's fine. You should be asking the companies that come pen test you guys to do this, to basically kind of step up their game. So and that's kind of why I'm up here too. So I know we're actually I think we're kind of a dying breed in some respects, but anyways, I digress. So modern attackers. So you're seeing a lot more memory techniques and a lot more often. So there's a lot of pen test teams out there that are using a lot of old tried and true methods, backdoors that live on disk. So we're actually reaching a point where malware is actually becoming more advanced than your average pen test, in my opinion. This is something that you should start to be looking for. I think it's going to become a lot more common in pen tests if you're not already seeing it. And again, if you're not, you should be asking for this. So a lot of people do pen tests, and they're very familiar with certain tool sets, but they don't actually understand how they work. That's kind of a whole other topic on its own. But offense, we use memory offensively. So Mimikatz is based on dumping the LSAS process. Target, POS scraping, so scraping credit card data. So you need to know how memory is structured and what you can do with it. So, and then injection, which we're going to talk about in a little bit. So, and a challenge to people who want to do pen testing, and you, as a blue team, you probably actually have a heads up on this, and a lot of people on the team. So I actually poke some of our guys in if you run an exploit, could you actually find that in memory? So just a question to ask yourself if you want to play around. Is that something that you could actually locate and find out? I know a couple pen test teams that are doing it, but it's something you can ask for. The companies that are doing this for you, can they tell you how to find their IOCs in a memory dump if given the chance? So a lot of smoke and mirrors happens on pen tests, so I think it's time for the industry to start being a little bit more transparent around those things. So, and then last but not least, so memory-based techniques. So there's a lot of stuff with memory injection that people have a lot of reliance on off-the-shelf software. We're going to actually kind of demo some of that in a little bit. Understand that detecting one way of detecting one kind of memory technique, there's a lot of different ways to do it. So somebody that can take one of these, git clone and grep it and replace a few strings can dramatically change some of the signatures you're seeing online. So just something to keep in mind. So memory friends at a glance, I can take this. I got it.
You got it.
All right. So who here has worked with memory at all? Memory images, scrapes at all? Okay, good. See, that's why I put this slide in. So memory forensics at a glance. So what can you do with a memory capture? So go into an operating system, and we're going to talk about a little bit more about acquisition on the next couple slides. But so this information that you're seeing up the slide, I'm not going to read it all off. This is stuff that you can pull out of a memory scrape. So if you can dump memory from a machine that's compromised, you can get all this information from a memory scrape. I've got a couple asterisks on there. So event logs, memory. So we're only talking about what's actively loaded at that time. So plain text passwords, that requires some certain settings be enabled. So I won't get too deep into that as far as what you can read. But if you dump a Windows 7 box, more than likely you can see some of these plain text passwords. So, but yeah, so basically, this is a ton of information for somebody that's doing defense, working in a SOC. So This is all within your reach. And from an offensive perspective, I am not happy if you guys can capture this in motion, right? So if you guys image a box that I've owned, not too big of a deal. If you shut it down, you've lost everything that I care about, really, for the most part. So just understand these are some of the things that you can actually grab when working with memory capture. What's that? Oh, so Yara, yeah. So I have an exclamation point. Thank you, sir. So Yara is basically, think of it as an open source command line driven antivirus. So you can basically write your own signatures. It's extremely easy to write rules. It's made by VirusTotal, right? They own Yara now. Anyway, so if you can identify bad, you can write a very simple rule for it and very simple criteria for rules. And essentially kind of write your own antivirus, and there's ways to run it against a network, memory, and file on disk. So very powerful tool. If you're not using it on defense, I highly recommend checking it out. So, because it's a pain in the ass when somebody has written a Yara signature for something. So, especially on the fly. All right. So, all right, acquisitions. A lot of different options here. This is not all-inclusive, and in the current age of technology, it changes every day. So first one, Ben already mentioned it, Recall. So that is a Google fork of Volatility. We'll do a Google GER talk one of these months, and we'll actually talk about it. But so Recall, one of the awesome things about Recall is it's a little bit more than your traditional memory scraping because you can actually query the memory live. So the way a lot of companies are using it now is instead of doing a full memory scrape, they're actually pushing out a job to all these agents, and they're asking, hey, what's in this chunk of memory on all of my workstations right now? So if you find something bad, you can go out, instantly reach into memory, and pull out that thing that you're concerned about. Redline, so I think everyone knows who Mandiant is. If not, Google them. They're important. As far as some of the PDFs that they've written. FTK Imager, so there's a whole lot of options. If you're wanting to get started, Redline and Dump It are, Redline, Dump It, and Recall are free. I would recommend, if you've never done a memory capture before, grab Redline. This is not me pimping that company, but it's just saying it's probably the easiest way to get started. If you're looking to just generate a raw memory image, I would check out the Dump It tool on Windows. And Recall, learning curve is going to be a little bit higher. Dump It has been around for a long time. It's the same company that used to do the WinDD. So yeah, so Linux, so I would say 90% of the memory-based stuff I do is on Windows. So, but I've run into situations where you need to work with Linux memory captures, and then OS 10 for those people that manage OS 10 networks, the two of you in the world. So anyways, there's more than that. I'm kidding. So I'm working on a Mac. So so yeah, for just a quick recap for Linux, I want to touch base. So you have Recall, you have FMEM. So Lime is probably the de facto standard, I think, if you're doing anything, if you want to do full dumps. It's basically a kernel module that you can load up. So, I just wanted to add this in here. It's in resources, I think, but you can get a known good copy pre-compiled Lime module from US Cert. They host a repository of pre-compiled for every Linux kernel version ever, so including Solaris. It's amazing. So remote acquisition. So this is, you're starting to get into a more managed process. If you're at a bigger company, I would hope that you probably have some kind of way to remotely acquire memory. I mean, Windows environment, there's a lot of different ways you can run commands remotely, PSXSec, which is awesome. And there's a lot of other tools. If you were to stand up something today to look at it, I would probably take a look at Google GER as far as a free agent that you could load to do hunt with. And then VM acquisitions. I wanted to talk about this because that's actually how we pulled the memory from some of the stuff we're going to look at tonight. So a large amount of companies are using VMs, and it's actually pretty interesting to watch people do forensics on, say, like a VDI, a set of VDI images versus like physical computers. It's actually a lot easier to get memory scrapes unnoticed, so it's a pain in the butt. But we were actually working with some VMware images today, so you can see the VMSN. So basically, just to I'm not going to go deep into the process, but to get a copy of the VMware image, you basically can just snapshot the machine and copy a file off, and it's that simple. So if you're working with any kind of virtualization, VMware Player, and you want to start working with VMware images, but you don't want to mess around with the software, snapshot the machine and just copy the memory. So, all right, analysis. I'm going to keep going. You just yank it out of my hand when I screw it up. All right, so Redline. So yeah, so Redline does a decent job at memory analysis. One of the big things about Redline, it's GUI based, so it's really easy to use. You don't have to be comfortable with the command line. You can get a lot of good information out of it. Side note about the Redline collector is it collects more than just memory. It does a whole lot of disk-based forensics. It does a whole lot of stuff at the time of capture. So if you're analyzing a memory image that you captured through another method, Redline might not be the best choice. So Volatility is probably the de facto, I don't want to call it standard, but if you ask somebody to check out a memory image off the street, they're probably going to find Volatility in the Google search ranking before anything else. So, and then Recall, which we'll talk about a little bit more in depth later on. But it's basically Volatility. Google took it, and they're doing their own thing with it, but it's publicly available, and you can do some really cool individual process stuff with it. So, oh, I had a demo. All right.
Well, you set that up. Let me just talk about it.
Sure.
A couple differences between Recall and Volatility. So Volatility uses parsing, heuristics to work its way around the memory structures, whereas, and so the problem with that is Windows 10 came out and Volatility, like it took it a little while to get able to use it. And if you tweak Windows 10, that thing updates all the time. They have to tweak it in accordance. Recall uses symbols directly from Microsoft, so they were ready for Windows 10 like almost right away. So there's a number of differences between those two tools. I think they both do really neat stuff, but they have a different methodology, and that's why they forked and they decided not to remerge themselves.
All right. So just as he was talking about, so Volatility uses a different kind of method to basically read and parse memory images. So one of the first things you're going to do when you get a memory actually, yeah, that is very tiny. 1 second. Please hold. So,
I believe it's up in the top where it's the global bar. You should select U. That's cheating.
Shh. Nice.
all right, there we go. More readable. If I need to make it bigger, let me know. All right, so one of the first things you're going to do when you're working with a memory image, and apologize, we kind of ran out of time as far as covering acquisitions more in depth. If you want, come grab me after, and I will be happy to spend time and walk you through it. So, but I've got a memory image here sitting on my desktop. So you grab Volatility, point it at the image, ignore the cache right now. I'm basically cheating, so this goes fast while we're doing the demo. And I'm going to run an image info against it. And so the reason I need to do that is I need to understand what memory image I've been handed, or just confirm what operating system I've been given, and then identify the exact profile that I need to use to parse that image.
Service pack.
Yeah, service pack, architecture, et cetera, et cetera. So this is going to be the first thing that you look at. So, all right, you can see here, so it's returned a lot of different information here. The date, the processor architecture, the memory access type. So we're just going to go ahead and take the latest profile and put that in. So one of the things, so this just came out in May, June. They started adding build numbers to Windows. And we'll actually get into that a little bit more depth, because software is changing so fast now that this profile method's kind of falling behind. Stuff changes pretty rapidly, and so stuff sometimes doesn't line up in memory how it needs to. So you'll notice there up at the top, so we've got Windows 7, Service Pack 1, x86, and then an actual build number. And then we've got just a generic Windows 7 Service Pack 1. So this is a fully patched version of Windows 7, so which no one is using because there's newer operating systems out. So let's go ahead and paste. Okay, so first thing we'll do is we're just going to run a So grab the image. I'm going to attack that info. So this is a list of all of the commands that I can run against this particular memory image. So you can kind of ignore, you see here the Linux and Mac commands. We'll ignore those for now. The other thing I guess we haven't mentioned is volatility is extensible. So it runs based on plugins. So any person can go out, write a plugin for volatility, if you know Python, and write some kind of a plugin that can examine the memory and return specific search results. So, and we'll talk about that more in a little bit. So probably some top things of interest right off the bat. So we're just going to go ahead and run a PS list, which is going to return a list of the running processes at the time of the memory dump. So we've got a list of running processes here. So we've got the name, the offset, that's where it's actually physically located in memory, the process ID, and the parent process ID, and the start time, and the number of handles that's open for that process. So which can sometimes be an indicator, sometimes not. So, and let me go ahead. So the next probably big item of interest for most people, since we're dealing with attackers that are hopefully not plugged in at your desk, but could be, is the net scan. So this is basically net stat based off of memory. So, and I wanted to kind of highlight this because we're going to talk about it a little bit later. So, but again, you can see, so we've got a list of protocols and addresses that are listening. We don't have any connections here, which we'll show later on. And then we've got a associated PID that it's mapped to, and as well as the owning process, and then the state. So,
can I mention one thing?
Yeah.
This might be enough to find some evil. So like svchost.exe, like that's probably one to look at because, right, our brains are wired to like read it the right way. What if it's scvhost.exe? Like right there, you know something's wrong. You could check if it's signed. There's other stuff you can do, but like even this little bit of info that Nate's doing on a memory might be enough. It's not for what we're going to show you later, but it's still really valuable, and you should really pay attention to not only the PIDs but the process names. Launch times?
Yeah, launch times. All right, so let's see. Didn't really have a script for the demo because those are terrible. So another one thing that I'll mention with volatility that I actually don't think we have a good slide on is let's do PS list H. So, and this is actually used, didn't talk about it, but so you can actually control the output of volatility. So it's going to be dependent on the plugin, but all that output you saw printed to the screen, we can dump that to a variety of different formats. So many of which are very easily processable by like Elasticsearch. So a lot of the cases where I'm seeing volatility used is actually somebody running it programmatically and dumping the information that it produces in a database somewhere. So for easy access for analysts. So there's actually an open source project you can take a look at. It's got a Docker image, so it's super easy to set up. It's called Volatility. Didn't have enough time to get it fully up and running for this and get the images loaded, but it's basically got a web GUI for Volatility, and you can dump multiple images and kind of cross-reference in between them. So, but we'll talk about that a little bit more. We wanted to just kind of show you kind of the classical way first. So you can get in and kind of start using volatility and playing with memory images. So, but yeah, just understand that that text on the screen is not your only option. So if you want an Excel file or a SQL database even, there are a lot of different options there. I'm not going to press my luck. There's actually also a visualization. You can actually print out a graph. So, but I don't feel like that's a lot of demo failure right there. I can feel that.
I'm with you.
So, all right. So I mean, I think that covers pretty basic usage. As far as, hey, I've got a memory image, this is how I tell what's in it, and then just some basic commands and how to look for more commands. So there's a lot of stuff that you can play around with, and that comes with the default volatility. So, all right. All right, so live demo done. So we basically baked up a kind of a scenario that we're going to kind of work you through to give you a little bit of the logic that goes behind into what happens and just kind of a basic malware scenario. So Ben's going to talk through kind of essentially the blue portion. I'm going to talk through the red portion. So I was mean and kind of a dick when I set some of this up. So we had kind of a cursory idea of how we were going to do this as far as what some of the initial methods were, but Ben did not have all the information. So a lot of this was analysis on his part as far as actually finding out what and where. This is probably the first time Ben's seen this. So scenario behind the attack. So my first step was I picked one of my terrible domain names that I have out there floating around that I use for demonstrations. Usually something flagrant, I think is the right word. Using a standard open source attack platform called PowerShell Empire. Using a standard C2 profile, so basically the way it communicates back and forth with whatever's controlling it. So, and something that a lot of people might not understand is a lot of modern day pen testers and malware even can use jitter. So just because you don't see a live connection on a machine all the time doesn't mean that there's not a connection there that's going to happen intermittently. And a lot of that's customizable. And to give you an idea of like a long-term pen test, I've seen callback times, which is the time that my malware takes to basically phone home, sometimes 8 to 12 hours, and that can be on the low side. So, and then understand that there's randomization that happens in there. So, in this case, I give it a 5-second delay and then a jitter of half. So the malware phones home every 2.5 to 7.5 seconds. So pretty not low and slow. So cooked up a Windows 7 fully patched image with IE7 and Windows Defender. So I'm not going to bag too much on antivirus, but it did have antivirus on it. So set up an email alias, which I then subsequently phished. So go me. No, basically just kind of setting up, trying to work towards a realistic scenario. So CEO Dave, poor Dave, was phished with a malicious HTA file. So executed in memory, so no actual file on the disk. And then I worked with the malware to inject into a process. Again, Ben knows none of this. And then I ran some bad things, so for fun. So before I hand it back to Ben, I wanted to kind of dig into a little bit. So bullets 7 and 8 are kind of what memory forensics are all about right now. So I'm going to kind of dig into those a little bit, give you a little bit understanding that we're on the offensive side. So
I got one thing. This is old school. So jitter is not all that new. There's an old language called expect. Anyone ever used expect? For screwing with switches and telnet, you had a jitter directive so it could be like a human was typing. So just a shout out, because it's old school and jitters, it's cool, but we've done it before.
All right, so talking about bad stuff like jitter. When I talk about injection, there's actually several different injection methods. So we're only going to talk about one here, but I hope this kind of primes you guys' understanding that there is a lot of way that bad things can be on a box that you will not see in Task Manager, that you will not see in the command line, in history, that you're only going to be able to find through something parsing memory somewhere. And there's some techniques that you can do this live, but for the most part, you're probably not going to work with those right off the bat. And you're going to need to understand how things function before you get to the point where you're using a lot of live forensics. So reflection, geez. So I am not a programmer. I did not go to school to be a programmer. So not my forte. So, but basically, the too long didn't read is the ability for code to self-modify. So basically, it's the ability to tell a piece of code to expand itself, which if you know anything about programming and a little bit, it's pretty amazing, and it's actually pretty cool. So back in the day, we used to have a lot of static processes. When you loaded a program, that was it. It's cool. There's a lot of ways that you can actually build stuff nowadays to actually load stuff after the fact or dynamically load stuff. So this is a fairly new this is not a fairly new technique. It's been around for a long time. If you've ever used Meterpreter and used migrate, and then you've used a function of injection and reflective injection for like a long time now. It's been in Meterpreter. So the most standard version of it bypasses a lot of Windows API calls, which is how a lot of endpoint detection actually picks this stuff up. So I'm not going to get too far into the weeds as far as how it actually works. But basically, it's going to require your bad guy, your adversary, to have some kind of code execution on the box. And with that execution, they have enough privileges to modify an application, so either user space, so a standard user or system. And they're able to basically bootstrap themselves into that application and then dynamically load something. And that something that gets loaded never touches the disk. So you're talking about something, think of it from basically an exploit. I exploit your browser. There's a weakness in Internet Explorer or Chrome or Firefox. And none of the code I've written ever touches your disk. So, and if you know anything about modern day antivirus, most antivirus requires something on disk to read to actually fire. So this is going to automatically break most antivirus. So, and the net effect from this is actually you're going to see a target process, and we'll dig into this a little bit. So you have Task Manager open, and you see a normal process list, but I have malicious threads, so basically points of execution hanging off a legitimate process. So, all right, so one more thing to cover. Reflective picks. So this is another technique, a little bit more of an obfuscation technique. So once I'm on the box, I have code injection, I'm hanging under another process, I still want to be able to run my payloads, my PowerShell, my bad stuff. So instead of me having to spin up a new process to run my stuff, I'm going to actually basically load some of the bits that make PowerShell run, the dynamic link libraries, into this process. And that's going to enable me to run PowerShell commands. And this is standard off-the-shelf software, so any 12-year-old can download this and do this at home as far as technique. So it's not anything new. And the way that PowerShell Empire works, it's fairly easy to detect. But one of the things I see a lot is that a lot of companies block PowerShell or restrict it, so that doesn't really do anything. If you have code execution on a box, it may funnel how you have to watch for it, but it's not going to restrict you from running bad stuff. So I don't know if you have anything.
No.
Okay, well, that does. All right. All right. So, all right, there you go.
All right, so Nate gave me those two images you saw earlier. These are the commands I ran. I'll just walk you through them. So I use Volatility in a stock Ubuntu laptop. It's a pretty big laptop. One of the guys on my team asked me if it ran diesel because it's really big and old, but it works. All right, so I got the images. I made a symlink, so I called it Volatility, but I linked to the binary that's really long that you download. Went ahead and looked at image info. You saw Nate do that first. Oh, I see what's going on here. He gave me baseline and malware, which is nice. I had before and after. I didn't really need to go to baseline too much, but it's important that it's there. So first thing I did is I ran PS Crossview. So that's number 2. And that does PS list, but a whole bunch of other checks. Runs like 3 or 4 plugins, and then prints out, and you'll see that in a little bit, a number of different statistics. And actually came back pretty clean. So I'm like, damn it. All right, what's next? Well, let's see if Nate left any command line artifacts. So I ran command line against that same image, and it came back pretty clean. So I'm like, well, this kind of sucks. All right, that's fine. We'll run malfind, which looks for evidence of malware, and dump that out. And I did that, and there was some garbage, and I ran strings against it. It was about 5 or 6 files, and there still wasn't much there from that stock plugin. I'm like, all right, well, let's just see what's running for DLL lists. So I ran number 5, and I got a whole, every process that's running, it shows you all the loaded DLL. So it's super noisy. So I just like put that to an output file. I'm like, I'll get back to that later. Then I ran NetScan. You saw Nate run that earlier. And I'm like, well, let me see what's running. I'll see the PIDs. I'll see if there's any listeners, any connections. You know, and that should get him. He didn't do anything great there. And I didn't get anything. Anything of use without doing more analysis. So here's what we did. And I hope you guys can, yeah, that's big enough, cool. So first thing is I did that net scan, and I just grabbed for established. And as you can see, there's a bunch of stuff established. By the way, like, this is pretty CLI oriented, so I'll explain grep and awk and stuff if you want. And like, well, this kind of sucks. I looked up all those IPs in the second column. It's Microsoft, Google, Akamai. It's all like generally benevolent IPs. I'm like, this doesn't help me. And then that last column is the PID, and it's -1. So the PID, process ID, wasn't coming through, and that kind of pissed me off. But I looked at this, I'm like, well, I didn't really get anywhere here. All right, well, maybe it's not open. Maybe it's not established. Let's see what else is there. So looked for closed. So I ran close, I grepped for closed, same command, and I got a lot. And so I truncated the response to fit in there, but I went ahead and looked at all of the IPs that were closed. And so that second command I ran in the middle, right here, I essentially just wanted the IPs that were previously open that are now closed. So I ran awk to space that out for the second space section, did a sort unique, and I got just those IPs, 107, 13, etc. So I used a curl command with a parameter of the IP address, and I looked at all of them, and they were all generally like okay, and then I'm like, oh, this one's interesting. No security.fyi in Texas. So I thought that was interesting, but I still didn't catch Nate. I just thought this was interesting. It wasn't Microsoft, it wasn't Google, but I said that was kind of fun. All right, so I looked for close, so we're on to something. We got some breadcrumbs. Can you go to the next slide? So I wanted to go back to the services that are running. So I ran NetScan again, and I wanted to go ahead and get rid of anything that had the -1 for the PID. Just give me the real PIDs. Let's look at those. And then I wanted to see TCP because UDP backdoor, that's being a real dick. So let's just stick with TCP for now. And same thing, I wanted to get all the PIDs, so I used awk to go ahead and get, based on spaces, the 6th column, sort, uniqued it, and those are all the PIDs. So let's look at the process associated with the PIDs. That's the table up top. So SVC host is notorious. Like, that's one I would go after just by default. But I looked at them, and I kind of like picked with each one, and then services.exe ended up being interesting. And I'll show you what I did with that. So remember earlier I said I ran DLL lists, and I got all this output. I went back and searched each one of those processes. And so this is the output from DLL list for services.exe with PID 520. And I did truncate it, there was a lot, but I'm like, why in the hell are these DLLs sitting in services.exe? Why is PowerShell sitting in services.exe? You can see assemblies or DLLs being loaded the last 3 lines. Like, that doesn't smell right. And remember earlier Nate gave me the normal image, the one before he infected it? Well, you can do a diff, and you can see this is not cool. So again, we see more breadcrumbs. So now we know there are some PIDs missing, but the PIDs that are resident and had some connections closed, this one's meaningful. This is different than the others. So again, we're onto something. We have a weirdo IP address. We have some weird shit running in services. Can you go to the next slide? So let's dump this thing. So there's a memdump command, and memdump doesn't just get the process, it gets the process in its associated memory space. So I dumped that thing out. So fine, that worked, it wrote it, 520.dump. So I want to look at the size of that thing, 345 megabytes. I'm like, damn it, that's huge.
So,
I'm like,
so I just want to interject here. So yeah, UDP, I don't know if it's super dick move. Services is a big dick move. So one of the things that you do with red sometimes is you realize that you're going to get caught eventually, so you make it as hard or as long as possible and as ridiculous as possible to search for stuff. So that was, yeah.
all right, so I ran strings against it. This is an easy way to see like what is in that thing. And I did a WC-L. I want to see all the lines, and there's 1,798,000 lines. I'm like, how the hell are we going through that? That's going to suck. So we looked at it, and I said, well, I want to see any EXE-based information in there. So that's fine. And then I want to see any lines that are 100 characters or more. Let's just start there. Let's just get the signal to noise ratio right down. So that's that grep command with the directive for 100 character lines or longer. Now I'm down to 19 lines. I'm like, okay, let's filter down to the 19 lines. So did that, and boom, this is one of the 19 lines. That's some shit. Like, why is that running in services.exe? PowerShell itself running there is weird. And then those other hidden directives, and I've seen those before in a pen test, by the way. Like, that doesn't look right. That's not cool. So I saw that. I chatted Nate, and I'm like, dude. He's like, yep. So we essentially did a couple of different steps here. Ran the standard volatility things that I think you want to look for. And the NetScan didn't give us the listener I wanted, but it gave us some interesting info. DLL scan way too much to get through. But when you get it down to the running PIDs, well, actually, I'm going to the next slide. I think I do a summary. Whatever, I'll just run through it anyways. Found the live PIDs, looked at all those, the DLL list for all of them, saw PowerShell and services, dumped the services memory, did a strings on it, 1.7 million, not going to happen. Carved it down based on some long string searches, saw this. So now I have some indicators of compromise. I found some stuff. I think we've gone far enough. I have the remote IP, which is the C2 server. We have some of the payload. We have where it's running. We've got, I think, enough here to then start scoping of the incident.
All right, so I think I might have reordered the slides.
That's all right. You want me to do this one?
Yeah, sure.
All right, so let's just recover what happened here. There's not a damn thing on disk. There's nothing on disk that could have been looked at. So the old DD stuff, other than maybe the swap file, maybe some of this shit isn't swap, but good luck. That'll be difficult to find. No bizarre service names. I didn't see SCV host. I didn't see anything weird there. And if you want to look at the actual, another way to check SVCO, see if it's clean, every time it's launched by the OS has a -K if you look at the actual command line. So -K means it's generally okay. No silly command line artifacts with the command line scan. No new PIDs. So that's why it's 101.5. It wasn't horrible, but it wasn't 101. So we want to look at known good state, sockets, and memory, and you can't do that with Nmap. So this was a little bit tough. What's next? All right, so I'm going to go to like IOCs, and I'll just touch on this. Nate, you probably want to talk more about this. Yeah. But that's an indicator of compromise. Information to enable hunting and IR teams to look for evidence of evil. They're artifacts. So they could be host-based, file name, hash. You've used some of these before, I'm assuming. Time-based data, et cetera. And then typically you may have some Boolean logic based on what you're using them in. This directory and this or this, and you can give it kind of a fine tune there. So network-based, think of your snort signatures, how you'd format those. And there's different other formats, and I don't have a ton of experience with these, but there's sticks, OpenIOC. You mentioned Yara earlier, which is more just for malware. It's not a general IOC type. But they can be simple as a registry key or much more complex. And Redline consumes OpenIOC because Mandiant wrote the OpenIOC standard, but I'm hearing a lot of good things about sticks. I don't know. But the sharing paradox, once you have this specific IOC, you may not want to share that based on what you're dealing with. If you're a massive corporation, you have an IOC for something that's special for you, you want to scope and clean that incident up before you share that IOC with the world. Because the adversaries are probably going to watch for VirusTotal or other places for that IOC to get shared. Findings or outcome, I kind of touched on these, but let me just run through them. So volatility, some patience, a couple beers, some command line stuff and problem solving. Here's what we found. PS Crossview and the command lines were clean. NetScan had a good output, but important PIDs were missing. That kind of pissed me off. We figured it out. PIDs were available. We looked at those, and they were all normally lame. Services.exe, svcos.exe. DLL list gives a lot of info, and because services was one of those interesting ones, we looked at it and saw PowerShell running. Dumped services.exe by PID using mendump, did strings, a little creativity, and we saw the PowerShell payload, one of them. I think there were 3 or 4. I don't know what you did, but I found enough, some of them, right? Correlated with no security.FYI, we now have IOCs. And I just want to show you an example of a real IOC. This is for Zeus. I know it's probably hard to read, but Zeus is some nasty malware, and it's all in an XML format. There's the or, the and, the Boolean stuff. This can be consumed by Redline, and then it could use it in your investigation. So these IOCs are very useful. I just want to give you and it's much bigger than this, a subset. All right, IOCs as incidents so far. So like, what would we actually do if we had to make IOCs? So we didn't code them up or make them. There's an IOC editor that's a GUI, you can use that. But services.exe with PowerShell DLLs in the process state, evil. Services.exe with a memory space that when parsed has encoded PowerShell commands, evil. TCP connection to the C2 server, and dude, it's port 80, use some crypto. I would use some crypto if I were being a dick.
I was trying not to be that big of a dick.
Okay, and you could add more with some research. PowerShell Empire IOCs, network-based IOCs, and then we didn't talk about persistence, but I'm always interested if the adversary has persistence. So you should talk about any persistence mechanisms you do or do not have.
All right, so in this case, what I was kind of going after to model, and I'll fill in some of the blanks that Ben probably has. And by the way, we did this, I think we had one phone call, so this is the first time I think both of us have actually seen this deck together. So anyways, this was in memory only. I actually had no persistence mechanism, so the attacker that I was modeling after was basically Dooku. So, which they're basically they rely mostly on memory infection, and then they have only 1 or 2 nodes that do actually true persistence. So A couple of things I guess I can add. So one of the things that Ben actually caught me wasn't actually the injection, it was the reflective pick. So actually loading that PowerShell assembly in memory probably made it a lot easier for him to catch it. And then the other thing too is most of the time, probably 99% of the time, you're not only going to be working off a memory image, right? You're going to have network-related incidents. So, but I've actually seen before where somebody sees a connection to a known bad, so no security FYI or some random site, Google, something.ru, but we couldn't find anything on the box that was actively making that connection. So it must be good, right? It was probably just a bad ad or something like that. It's all good. So that's definitely not the case. This is a process that you're going to want to utilize to kind of help confirm that information. You should be looking for bad also in memory. So let me check our next slide. Yeah. So we'll have this deck posted to SecDSM.org on the slide. So, and I'm more than happy to chat with anybody that has any questions after the fact, Ben too as well. And before we want to follow it up, so this was kind of a last-minute deal as far as putting this together. We wanted to basically kind of solicit feedback from you guys. So if you guys have thoughts on or feedback as far as the presentation, so Ben and I are both SecDSM board members, so we were interested in hearing your feedback. So do you like the format as far as having an offensive and defensive side? What topics do you guys want to hear? I think we're probably about 50-50 for guest speakers versus local speakers. We're working on that. So if you guys have any feedback at all regarding the presentation or anything, please feel free to email us or reach out on Slack and provide some feedback. So appreciate it.
I think that's it. I guess let's stop for a couple questions if there are any. Otherwise, we can just take them, offline too. But I want to make sure we answer some if they're of value.
So when you take a memory dump, how long does that take, and how much memory changes in the process, and how does it affect the image?
Okay, so great question. So whoops, that is not the right button. We're going to go back real quick to, let me see. Repeat the question.
Yeah, so the question was, when you go acquire memory, how much space does that take? Where do you put it, I guess? And then when you're acquiring it, memory is constantly changing, so there's a delta. What about that delta? Do you care or not? Is that accurate? Okay.
Okay, so yeah, the memory is going to take roughly approximately the amount of physical memory you have. Now that can flex based on how much memory you're rolling, right? So memory is a snapshot in time. So it's possible as you're capturing memory, it's going to roll over a slight amount. So I think there's probably about 100 meg difference between our clean image and the dirty image. And I think a lot of that is just because there was additional activity that happened. An actual memory capture, so the technique we used, it was a VM snapshot. So it literally took about a second. It basically forks the memory on disk, and then you can copy that down. If you use an executable process to pull that, or even a remote capture, you're probably only looking at about a couple minutes tops to actually dump the disk. So if you're doing it remotely, obviously you got whatever network copy time you've got pulling it back, but it's really not a long process. Now, one thing I will say is that there can be some, there's a little bit of discussion, I'll talk a little bit about law enforcement, Wes Jordan's here, about if a memory capture actually screws up your chain of custody. So there's some discussion there. But I think most law enforcement's in agreement that no. But one of the reasons I want to bring that up is I've seen stuff crash during a memory dump. So just keep that in mind. You're touching a box, you're touching important bits on a box. So save that Word document with that macro before you run the memory dump. No, so just keep in mind that accessing memory, there's inherent risk in that. So anything else? Any other questions?
As far as acquiring, the one, and I'm old school, so maybe you can tell me this doesn't work, but F-response was wonderful. It deploys a little agent. So you are actually touching that remote machine, which 10, 12 years ago, that was like a faux pas. Like you don't touch your target. It has to be pristine, right? But I think that's changed. You can touch it with trusted code. So F-response runs with, there's a hardware dongle for licensing, installs a little agent, presents an authenticated iSCSI listener, and then over the network you can suck it down. And if you have a machine close to it, like on the same LAN, then you can basically get your memory image somewhere local, dump it, almost move laterally like a bad guy, and then turn that little service you installed off. And you can name it whatever you want. You can name it services.subra, I don't care, name it whatever you want. But I've had really good success with that in the past, but I'm pretty rusty, so I had to dust some of these skills off. So just give F-Response a shot if you're curious. I liked it.
Yeah, and I would say, so a lot of big companies, you probably already have some kind of remote capture agent, but it is still perfectly acceptable to thumb drive it, run something up, again, trusted code, or grab a disk and a thumb drive that you're burning, pulling that memory off. So not everyone has the same software capabilities, completely understandable, and not everyone, I'm sure in this room even has a full incident response. So that's a way to do it. So if you need any ideas behind that, feel free to grab others after. But all right. All right, I think we're done. Yeah, we're good. All right, so we're going to take about a 5-minute break. So if you are a first-time person here at SecDSM, there are stickers on the table off in the back there, so feel free to grab a sticker. So I appreciate you guys coming in. So SecDSM, we're community-based. So this is people that live in Des Moines and then some people that drive up from Kansas. I don't know why. So thanks, guys. So all right, about 5 minutes. And then we'll go for. Oh, just a really quick aside. So we've had a couple questions. One actually came up tonight. People asking about SecDSM and CPE. So a lot of people. I know we have some certification haters in the room. We have people that love certifications. It's fine. Don't carry either way. But for those of us who have to maintain certifications, we are a qualified organization as far as CPE. So the time that you spend here can be documented and recorded for if you have any certifications that require CPEs. So official process for that. So if you're ever audited for CPEs, you got to be able to prove, right? So just as a quick aside, so I would just recommend maybe taking a screenshot of the SecDSM calendar for that night, and that should give you more than enough information. So we're not anticipating going away, so we'll be happy to back up your call as well. So if you can provide proof that you were here. But anyways, just wanted to kind of mention that. I know there's quite a few of us that have to maintain CPEs, so this counts. So all right, thank you. 10 minutes.